Hello, this is Mrs. Scarple, and this video will cover topic 2.14. In this video, you will be finding logarithmic functions from tables or from information given to you in a context. You will also be asked to use those functions in solving. Just for reference, a logarithmic function model has the form y equals a plus b natural log of x, or y equals a plus b log x, where a and b are constants and b cannot equal 0. And the whole reason we can use logarithmic functions, the input values appear to change proportionally over equal length output intervals. Remember, if it's exponential, it's the output values that change proportionally over equal length input value intervals. So this is the inverse of that. It's that the inputs are changing proportionally. In our first example here, we have a table with two pairs of values, and we are being asked to use the function L of x equals a plus b natural log of x. And the first part of this problem is to use the data to write two equations that can be used to find the values for the constants a and b in the expression. So we are given an x value and its corresponding y value, or we're giving an input and its corresponding output. And we're going to replace the x behind the natural log with the input and L of x with the output. So for the first equation, I'm going to have 3 equals a plus b times the natural log of 2. And my second equation will be 7 equals a plus b times the natural log of 5. For part B, we need to find the values of A and B, and I know that this is getting a bit close to the bottom of your paper, so I'm going to do some of this work up here underneath the A. What I'm going to do is I'm going to solve one of these equations for A so that I can substitute it for A in the other equation. So I'm going to go ahead and rewrite 7 equals a plus b times natural log of 5 as 7 minus b times the natural log of 5 equals a. That allows me to substitute into the other equation. So now I'm going to be solving the equation 3 equals, replacing a with 7 minus b natural log of 5 plus b natural log of 2. So the first thing I'm going to do is I'm going to subtract 7 from both sides. So I'm going to have negative 4 equals negative b natural log of 5 plus b natural log of 2. And then I'm going to divide everything by negative 1 so that this becomes a positive 4. So I'm going to have 4 equals, and I'm going to factor out a b at the same time. So b times natural log of 5 minus, oops, forgot the 5, natural log of 5 minus natural log of 2. So again, I did a couple of things here. I was dividing everything on both sides by negative 1, but also at the same time factoring out a b. So what we can do is we can condense the natural log of 5 minus the natural log of 2. So that becomes b times the natural log of 5 over 2. or the natural log of 2.5. So when I solve for b, I'm going to end up dividing 4 by the natural log, and I'm just going to go ahead and use 2.5 because it is exactly 2.5. It'll just look a little bit neater for writing. So the exact value of b is 4 divided by the natural log of 2.5. So down here under b, or part b, I'm going to write that b is approximately, I'm going to grab my calculator, I'm going to pull it over just so I can see what I'm doing here. That's not what I wanted to have happen. Here we go, let's try this again. Okay, so 4 divided by the ln on your calculator is natural log. I changed it to 2.5 so I don't have to worry about it being a fraction, and enter, and we have approximately 4.365. So 4.365 is my approximate value for b. Now to find b, to find a, I just need to substitute the value for b into my equation. And I'm going to use the exact form because we should always use exact forms when finding anything and rounding at the very end. I'm going to go ahead and use the first equation. So we'll have 3 equals a plus the natural log. Oops, it wasn't natural log, it was 4 divided by natural log, if I remember correctly. B is 4 divided by the natural log of 2.5. Times the natural log of 2. So now to find a, I'm going to take 3 and I'm going to subtract. I can write that as 4 times the natural log of 2 divided by the natural log of 2.5. That's going to equal my a in its exact form. Grab my calculator again, make my box a little narrower here so I can read everything. We have 3 subtract. I'm going to place that 4 natural log of 2 in parentheses. So that value divided by the natural log of 2.5, close my parentheses, and I have a is approximately negative 0.026 if I'm rounding it. If I'm truncating it, it's negative 0.025. So a is approximately negative 0.026. And we have found the values of a and b. Again, the reason I went out 3 decimal places is because on the AP exam, you either round or truncate to 3 decimal places. Moving on to example 2, we're given a table of values. And if you read through the first part of the top of the page on the front page of your notes, you know that they were talking about average pastor salaries and that it appeared to be a logarithmic function. So we have this table here that has the size of the church. And when we're talking size of church, we're talking church members and the average salary in thousands of dollars for the pastor of that church. We're going to use regression capabilities of a graphing calculator. I'm going to go ahead and do this with Desmos because I want to point out something that you have to be certain to do with Desmos. I think it might be automatically set on the AP exam, but in case it isn't, I need you to be aware of this. So we're going to use the regression capabilities of a graphing calculator to find the logarithmic function of the model, where P represents the church size and S is the average pastor's salary. And then once we have that function, we can predict the annual salary. So I have already taken the time to put this in a table in Desmos. Just to remind you, if you want to add a table, you press the plus corner and then table, and it will fill in that box. I have my, oh, I need to switch my, I wonder if I can. I have my values in the wrong order. So let's close this, or let's delete this table, and nope, I had done that correctly. Never mind. I did want it to go this way. Okay, so to get the regression, this little symbol that you see next to the table, it's dots with a line between it. We click on that for regression, and then you'll see it automatically gives a linear regression. We want a logarithmic regression. So we select on logarithmic regression, and we have to, this is what's different about Desmos compared to the TI graphing calculators or most other calculators. We have to set this in log mode. I believe log mode will already be defaulted on the AP exam, but you should check to make sure it's there. So we have our equation, and I am just going to, let's see, oops, I'm going to make note of it. I have it written out as a truncated on my paper, so I am going to take that equation and I am going to write it as S of P. So P would be the X on that table, equals, as a truncated, it's negative 91.542 plus 29.908 times the natural log of P. Now, Part B is saying use the model found in Part A. What is the predicted annual salary in thousands of dollars? On Desmos, that's really simple to do. On the TIs, we just have to save this equation and then find f of whatever or y of whatever. So we save the equation on a TI. Here, I'm going to click on this little box. I export it. I give it a list. I'm also going to change y to say f of x so that I can say, okay, what's my value when there were, double check my number here, 500 people. So replace this x with, or nope, never mind. I don't want to place it there. Right below, I'm going to type f of 500, and it gives me the value. So we've got 94.329 thousand people, or actually we're talking dollars, so we might as well round it to the nearest whole dollar, so $94,330. How, I'm not sure. I would I would leave it at, you could say 94.329. I know I sound kind of like I'm rambling here, but what we could do, in case we're worried about the decimal piece, is we could say we have 94.329, and then we have to say thousand. Dollars is the predicted salary. Give myself a little bit more room here. For a pastor, at a church with 500 members. You want to be very explicit when answering these problems on the AP exam. You want to give the value as specifically as you can and what it is representing. And this concludes my video for topic 2.14.